Imagine a building that contained all human knowledge. Every scroll, every discovery, every mathematical proof, astronomical chart, and engineering blueprint from across the known world. All in one place. The year's 280 BC. The city is Alexandria. And on the Mediterranean coast of Egypt, something unprecedented is rising. Not just a library, a cathedral of knowledge, a factory of innovation, the intellectual heart of civilization. This is the story of the Library of Alexandria. Before Alexandria, knowledge was scattered. Athens had its philosophers, Babylon had its astronomers, Egypt had its engineers. But there was no center, no place where ideas could meet, combine, and evolve. Knowledge died with its creators. Libraries burned. Wars destroyed centuries of accumulated wisdom. So in 283 BC, Ptolemy founded the Great Library and Museum of Alexandria. And he didn't just build a library, he built the world's first research institution. Ptolemy issued a decree. Every ship that docked in Alexandria's harbor had to surrender its books, Greek texts, Egyptian papyri, Persian tablets, Indian manuscripts. Within decades, the library held over 500,000 scrolls, the sum total of human knowledge under one roof. This is where Euclid systematized geometry, where Eratosthenes calculated the Earth's circumference, where Ctesibius invented machines that wouldn't be matched for millennia. For nearly 600 years, Alexandria was the center of the intellectual world. But then came the fires. 48 BC. Julius Caesar's accidental fire destroys part of the library during civil war. 391 AD. Christian decree orders the destruction of pagan temples, including the museum. The fires continued. The knowledge burned. Papyrus curling and blackening. Centuries of mathematics, medicine, engineering vanishing in smoke. The actual blueprints, the detailed mathematics, the experimental data, gone. Scholars rushed to save what they could, clutching scrolls, running through smoke, desperate to preserve even fragments. But for every scroll saved, hundreds were lost. Say 42 AD. The final scrolls were reportedly burned. Within centuries, 500,000 scrolls reduced to ash. The halls stood empty, shelves carbonized, knowledge that took millennia to accumulate, destroyed in moments. Think about what was lost. We know Alexandria had advanced mechanical engineering because we found fragments, but we only have fragments, summaries, second-hand accounts. How many cures for diseases were written on those scrolls? How many agricultural techniques, how many architectural innovations that could have prevented famines, plagues, or collapses? We'll never know. The Library of Alexandria proved two things. First, when you concentrate knowledge and brilliant minds in one place, innovation explodes. Breakthroughs happen faster. Progress accelerates. Second, when you destroy knowledge, you don't just lose information. You lose time. Every medical advancement we had to rediscover. Every mathematical proof we had to rederive. Those weren't just delays. Those were centuries of human suffering that could have been prevented. Today we're building digital libraries, cloud servers, distributed archives, redundant backups across continents. We're paranoid about preservation, and we should be, because we learned the hard way what happens when knowledge burns. The Library of Alexandria showed us the power of collected wisdom. Its destruction showed us the cost of losing it. Every modern research institution, every university, every digital archive, they're all echoes of that one building on the Mediterranean coast. A building that proved humanity at its best could achieve anything, and a warning that humanity at its worst could destroy everything. Some buildings change the world by standing, others change it by falling. Alexandria did both. Alexandria, named after the conqueror who envisioned it, but built by those who understood something deeper. This wasn't just another city conquered by Alexander the Great. This was a deliberate creation, a planned center of the world. 280 BC. The city sits at the crossroads of three continents: Europe, Asia, Africa, all meeting here. Ships from Athens, Carthage, Persia, and India dock in its harbor. Languages blend in the streets. Greek philosophers debate with Egyptian priests. Babylonian astronomers share knowledge with Indian mathematicians. This is where Ptolemy chose to build not just a library, but a civilization's memory. Not just a museum, but humanity's laboratory. The architecture alone was revolutionary. Greek columns supporting Egyptian design principles, marble from across the Mediterranean, bronze fixtures crafted by the finest artisans, every detail calculated, every measurement precise. This wasn't decoration, this was engineering as art. In the harbor, the lighthouse of Alexandria, one of the 7 wonders of the ancient world, guided ships from across the known world. And those ships didn't just bring trade goods, they brought ideas, scrolls, knowledge. Every merchant vessel that docked was required by law to surrender any written materials. Scribes would copy them. The copies returned to the owners. The originals stayed in Alexandria. This was how you build an empire of knowledge. Through these columns walked the greatest minds of the ancient world. Euclid developed geometry here. Eratosthenes calculated the Earth's circumference with shocking accuracy, off by less than 2%, using only shadows and mathematics. Archimedes studied here before returning to Syracuse. Hero of Alexandria would later invent the first steam engine prototype, 18 centuries before the Industrial Revolution. And Ctesibius would change everything. But first, he had to arrive. A young man from a barber's shop about to revolutionize engineering, music, and timekeeping all at once. Ctesibius wasn't born into wealth. He wasn't educated in elite academies. He was the son of a barber. And it was in his father's shop that everything began. Not in the great museum of Alexandria, not in the halls of the library, in a barber shop. His father had installed a simple counterweight system, a mirror that could be raised and lowered with a rope and pulley. Practical, functional, nothing special. But Ctesibius noticed something everyone else missed. When the weight dropped, it compressed air in a tube. And that air made a sound. Whistling, humming, musical. Most people would have dismissed it, an annoying byproduct of a practical tool. But Ctesibius heard possibility. If air under pressure could create sound, what else could it do? That question, that one moment of curiosity in a barber shop, would lead to the water clock, the force pump, and the hydraulis. The world's first organ. He didn't have formal education. He didn't have wealthy patrons. He didn't have access to the museum. Not yet. But he had something more valuable. The ability to see potential in the mundane. While others looked at water and saw something to drink, Ctesibius saw pressure, flow, and mechanical possibility. While others looked at air and saw emptiness, he saw compressed power waiting to be harnessed. That question led him to the Museum of Alexandria. Not as a student, he was too old, too poor, but as an artisan. A craftsman who could build the devices scholars theorized about. And there, surrounded by scrolls and brilliant minds, something remarkable happened. The craftsman became the teacher. Before precision, there was brute force. For millennia, humans shaped the world with simple tools. Stone axes, wooden mallets, crude bronze implements. These tools built pyramids. They carved temples. They felled forests and shaped civilization. But they had limits. You couldn't build a water clock with an axe. You couldn't craft bronze valves with a stone hammer. You couldn't calibrate mechanisms to measure time in minutes with tools designed to fell trees. The leap from simple tools to precision instruments wasn't just technical progress. It was a revolution in human capability. The transition happened gradually, then suddenly. Artisans began demanding finer tools. Bronze workers needed instruments that could measure thickness in fractions. Astronomers required calibrated devices to track celestial movements with precision. And in Alexandria, where the greatest minds gathered, the demand for precision reached its peak. You couldn't revolutionize engineering without revolutionizing the tools first. Enter the compass, the ruler, the calibrated measuring device. Bronze tools so precisely crafted they could draw circles accurate to a hair's width, dividers that could split measurements into fractions, straight edges polished to perfection. These weren't just tools, they were extensions of human thought made physical, mathematics made tangible. With these tools, Ctesibius could engineer valves calibrated to millimeters. He could craft pistons that fit cylinders with perfect seals. He could measure water flow rates and calculate pressure with unprecedented accuracy. The water clock required precision the ancients had never achieved before. But now with these instruments, the impossible became merely difficult, and Ctesibius excelled at difficult. Alexandria, 270 BC. A young engineer stares at a bowl of water, not as a philosopher, not as a poet, as an inventor who's about to solve humanity's oldest problem. How do you measure something that can't be touched? How do you hold time itself in your hands? His name is Ctesibius, and in this workshop, surrounded by bronze tubes and marble bowls, he's building the world's first self-regulating machine, the water clock. For thousands of years, humanity struggled with time. The sun moved, shadows shifted. But what happened at night? What happened on cloudy days? You couldn't conduct business. You couldn't measure speeches in the courts. You couldn't coordinate ships leaving harbor. The Egyptians tried sundials, elegant but useless after sunset. The Greeks experimented with hourglasses, sand flowing through glass. Consistent, but impossible to restart without flipping. And here's the real issue. None of these devices could adjust themselves. A sundial doesn't know when summer becomes winter. An hourglass doesn't care if the sand clumps or flows freely. They were passive instruments, dead tools. What humanity needed was something alive, something intelligent, a machine that could think. Ctesibius understood water like no one before him. He knew it was predictable, reliable, and under the right conditions, it could regulate itself. His first insight was simple. Water flowing from a container creates consistent drops. One drip, then another, like a heartbeat, like a clock. But there was a problem. As water drains from a vessel, the pressure changes. The flow rate slows down. Early morning, the water rushes. By afternoon, it crawls. So Ctesibius engineered a solution that wouldn't be matched for over a millennium. He built a feedback system. Here's how it worked. 2 vessels. One main reservoir, one overflow chamber. As water drips into the receiving bowl, a float rises. Connected to the float is a valve controlling the inflow rate. When the bowl fills too quickly, the float rises, the valve restricts. Flow slows down. When the bowl drains, the float drops, the valve opens. Flow speeds up. Automatic correction. Mechanical intelligence. A machine regulating itself without human intervention. For the first time in history, technology was thinking. But Ctesibius didn't stop there. He added precision markers, hour lines engraved in bronze, a pointer attached to the float. As the water level rose, the pointer moved past each hour marker. Constant, reliable, accurate to within minutes per day. And for the truly ambitious models, he added automata. Little bronze figures that moved as the clock advanced, birds that sang, doors that opened, bells that chimed, all powered by the steady, unstoppable flow of water. It wasn't just a clock. It was a symphony of engineering. Bronze tubes calibrated to the width of a human hair. Marble bowls polished to perfect smoothness to ensure laminar flow. Valves that opened and closed with the precision of modern machinery. No electricity, no springs, no batteries, just water, gravity, and genius. The clepsydra became more than a timepiece. It became art, engineering as sculpture, function as beauty. The wealthy commissioned ornate versions with miniature temples, golden figures, and jeweled decorations. But beneath the ornamentation, the same brilliant mechanism ticked away. The principles Ctesibius developed, feedback loops, self-regulation, automated control. These are the foundations of modern automation. Your car's cruise control, feedback system, your home thermostat, self-regulating mechanism. We think of automation as a 20th century invention, Assembly lines, computers, artificial intelligence. But the truth is simpler and more profound. Automation began with a bowl of water and a floating valve in ancient Alexandria. 2,000 years ago, Ctesibius didn't just build a clock. He built the first machine that could think for itself. The Library of Alexandria wasn't just a repository of scrolls. It was a laboratory, a workshop, a forge for ideas. In its halls, knowledge met practice. Theory became engineering. And Ctesibius wasn't working alone. He was surrounded by the greatest minds of the ancient world, all pushing the boundaries of what was possible. Euclid was systematizing geometry. Archimedes was discovering the principles of leverage and buoyancy. Eratosthenes was calculating the Earth's circumference using shadows and mathematics. And in the workshops, craftsmen were turning these theories into reality. Bronze gears, pneumatic systems, mechanical marvels that wouldn't be matched for centuries. This is where pneumatics was born, the science of compressed air. Ctesibius's water organ, the hydraulis, used air pressure regulated by water to create sustained musical notes. Centuries before the pipe organ, Alexandria had mechanical music, powered by hydraulics, controlled by keyboards, engineering as art. Hero of Alexandria would later build on Ctesibius's work. He created the Aeolipile, the world's first steam engine, a bronze sphere spinning on jets of steam. 18 centuries before the Industrial Revolution, Alexandria had discovered steam power. They didn't industrialize with it, they didn't need to. But they proved it could be done. Hydraulic pistons, force multipliers, mechanical advantage calculated to perfection. These weren't crude implements. These were precision machines. Bronze cylinders machined to tolerances measured in fractions of millimeters. Leather seals treated with oils to maintain perfect compression. Valves that opened and closed with split-second timing. Gears within gears. Compound leverage. Reduction ratios that multiplied force by factors of 10, 20, 100. Systems so complex they required mathematical calculations to design. But once built, they worked flawlessly, moving massive weights with the turn of a hand, precision where others had only brute force. These weren't just machines, they were proof of concept, demonstrations that human ingenuity could bend the natural world to human will, that water could be controlled, that air could be harnessed, that time itself could be measured and mastered. The Roman Empire would adopt these technologies. Byzantine engineers would refine them, medieval craftsmen would preserve them, and at the center of it all, Ctesibius. Not just inventing machines, inventing categories of machines, creating the foundations of hydraulics, pneumatics, and automation. In workshops scattered throughout Alexandria, the future was being built, one bronze gear at a time. Rome is burning. The year is 100 AD. Flames consume entire city blocks. People flee. Buildings collapse. But in the chaos, a group of men rushes toward the fire, not away from it. They're carrying a machine. Bronze cylinders, wooden levers, a nozzle that gleams in the firelight. One pulls, another pushes. Water erupts from the machine with impossible force. A sustained jet, continuous pressure. Power that defies gravity itself. This is Ctesibius's force pump. For millennia, fire was unstoppable. Once it started, you had two choices: run or watch everything burn. Bucket brigades were useless. By the time you formed a chain, the fire had spread. By the time water reached the flames, it was too late. The problem wasn't lack of water. It was lack of pressure. You could throw water on a fire, you could dump buckets, but you couldn't push water with enough force to penetrate deep into a burning structure. Ctesibius understood pressure. The force pump was brilliant in its simplicity. 2 bronze cylinders, 2 pistons, 2 one-way valves. You pull the first lever. The piston inside cylinder 1 draws water up from a reservoir. At the same time, the second piston pushes down, forcing its water out through the nozzle. Then you push the first lever while pulling the second. The motions reverse. But the water never stops flowing. One cylinder always fills while the other always empties. Continuous pressure, uninterrupted flow, a jet of water that could reach 30 feet with enough force to penetrate flames. The pistons were wrapped in leather soaked in oil to create airtight seals. The valves were bronze flaps that opened only in one direction. Perfect mechanical execution. For the first time in history, humans could fight fire with more than hope. They could fight it with engineering. Two men working in rhythm. Pull, push, pull, push. Water flowing without interruption. Pressure sustained. Power unleashed. The jet of water arcs through the air. 30 feet, 40 feet. Hitting the flames with force. Steam erupts where water meets fire. The men don't stop. Pull, push, pull, push. The rhythm never breaks. And slowly, impossibly, the fire begins to retreat. Rome adopted it immediately. Fire brigades, the vigils, carried them through the streets on wheeled carts. When flames erupted, they'd rush in, set up the pump near a fountain or aqueduct, and unleash sustained jets of water. Buildings that would have burned were saved. Neighborhoods that would have vanished were preserved. But the applications went far beyond firefighting. Mines used force pumps to drain water from deep shafts. For the first time, miners could reach ore deposits below the water table. Fountains in public squares used them to create spectacular displays. Water shooting upward in defiance of gravity. Ships used them for bilge pumping. The wealthy commissioned ornate versions. Bronze polished to a mirror shine. Decorative engravings. Golden fixtures. But beneath the ornamentation, the same brilliant mechanism. The same double-acting pistons. The same one-way valves. The same genius that saved cities from fire. The principle, double-acting pistons with one-way valves creating continuous flow, became the foundation of every pump, compressor, and pneumatic system that followed. Your bicycle pump? Same principle. Your car's engine? Same principle. Modern firefighting equipment? Still using variations of Ctesibius's design 2,300 years later. The force pump wasn't just an invention, it was a category of machine that had never existed before. Ctesibius gave us the power to fight back. And every fire extinguished since then, every life saved, every building preserved, carries an echo of that workshop in Alexandria, where bronze cylinders and brilliant engineering defeated humanity's oldest enemy. Some battles aren't won with swords, they're won with pistons. Who was he? The man who built machines that thought for themselves, who measured time without the sun, who turned water into power and air into music. His name appears in fragments, mentioned by scholars centuries later, praised by engineers who came after. But who was Ctesibius of Alexandria? Not just what he built, not just what he invented. Who was the man who changed everything? We know almost nothing about him. No portraits, no detailed biography, no personal letters or journals. Everything we know comes secondhand. But here's what we do know for certain. Ctesibius wasn't wealthy. He wasn't royalty. He wasn't educated in elite academies. He was a craftsman, a maker, someone who worked with his hands. And somehow, in a world where knowledge was controlled by priests and philosophers, this craftsman became the greatest inventor of the ancient world. The hydraulis, the world's first organ. Water regulating air pressure to create sustained musical notes. Before Ctesibius, music required human breath or physical vibration. After Ctesibius, machines could sing. The water clock, self-regulating, correcting its own errors. The first machine that could think. The force pump, double-action pistons, continuous flow, the power to fight humanity's oldest enemy. He didn't just solve problems, he solved categories of problems. His devices weren't innovations within existing frameworks. They were new frameworks entirely. Before Ctesibius, there were no self-regulating machines. After Ctesibius, automation became possible. Before Ctesibius, there were no continuous flow pumps. After Ctesibius, hydraulic engineering exploded. He didn't improve existing technology. He invented entirely new categories of technology. But success came with a price. Ctesibius was brilliant, but he was also mortal. We'll never know what Ctesibius looked like. We'll never read his own words. We'll never see his original blueprints. But every time you turn on a tap and water flows with consistent pressure, every time you hear an organ and music fills a cathedral, every time a machine corrects itself without human intervention, Ctesibius is there. Not as a name on a monument, as an invisible foundation beneath 2,000 years of innovation. He had no illusions about immortality through fame. He was a craftsman. Craftsmen don't get remembered. Their work does. And that's exactly what happened. His ideas, his principles, his innovations, they're everywhere. Not the name, not the fame, the function. Some inventors are remembered for their genius. Others become the genius itself. Silent, essential, eternal. Ctesibius chose the latter, or maybe it chose him.